Hi everyone, this is lesson 3-1, quadratic functions. Our learning target for today will be for students to be able to use vertex form to write the equation of a quadratic function. Today we will talk about vertex form of a quadratic function. So far we've talked about standard form of a quadratic function, and what we're going to do today is just talk about another way to write an equation of a quadratic function. When we talked about linear functions in chapters 1 and 2, we talked about slope-intercept form, point-slope form, and standard form as methods of writing a linear equation. And in this chapter, we will talk about standard form and vertex form as ways of writing the equation of a quadratic function. So there's a couple things that are wrong with the formatting on this slide. This equation right here, that 2 should be an exponent, so it should be y equals a times x minus h quantity squared plus k. And this is a parabola with its vertex at the point h comma k. So this value right here that you're subtracting from x is the x coordinate of the vertex, and this number or constant that you're adding on the outside, that value of k, is the y coordinate of your vertex. Now we talked about the vertex last week, about the vertex being a maximum or minimum depending on if the parabola opens upward. We talked about the lead coefficient out in front of the x squared term, determining whether the graph opens up or down. If a was positive or greater than 0, then the vertex is a minimum and the graph opens upward. So it's like a smiley face, like this. And the parabola opens downward if a is less than 0, so in other words if a is negative, and the vertex is at a maximum. So you would have a frowny face, like this, and your vertex would be at the top, at a maximum. The axis of symmetry, or line of symmetry, which we also talked about last week, has an equation of x equals h, meaning whatever the x-coordinate of your vertex is, that is your equation for your axis of symmetry. The a value is the same as the leading coefficient when your equation, again we have an issue with the formatting here, that 2 should be an exponent, so this should look like y equals ax squared plus bx plus c. And in vertex form, this a value is the same as the a value in our standard form. So the larger the value of a, the more narrow the parabola will be. If a is really big, okay, so if like a equals 3 or a equals 10, the equation with the lead coefficient of 10 is going to be more narrow, skinnier, than an a value that had, or an equation that had an a value that was 3. So you might compare these two parabolas. 10 would be the skinnier or more narrow parabola compared to a parabola or a quadratic equation that had a coefficient of 3. So just pay attention to your lead coefficients or your a values. The larger a gets, the skinnier or more narrow the parabola becomes. And if a is negative, you take the absolute value of that number and that compare those a values to determine how wide or how narrow the parabola is. So for instance, if I had a negative 3x squared compared to a negative 10x squared, the negative 10x squared is going to be narrower, because even though negative 3 is greater than negative 10, you look at the absolute value of your lead coefficient to determine which one is more narrow. Okay, in example 1, we are looking at an example where a ball is being thrown upward at 64 feet per second. and from the top of a 60-foot high building. We need to write the equation of the function that models the height in feet of the ball as a function of the time t in seconds. Well, we really know a couple things here. One is that we have two variables, time and height. H is measured in feet and time is measured in seconds. Well, we know that at time equals 0, the ball is 60 feet from the ground because we are on top, or the ball is on top of the building that is 60 feet high. So the ball's position with respect to the ground at this point in time is 60 feet. Now we are going to throw the ball upward at a rate of 64 feet per second. And so our rate, or our velocity, our initial velocity is 64. Now in your book, they give you an equation for modeling a ball that is thrown in the air. And this equation, y equals negative 16t squared plus v sub 0t plus h sub 0 is the equation they give you. Now, t obviously represents time. Actually, I could erase the y and make that an h for height. And v sub 0 is your initial velocity, and h sub 0 is your initial height. So in this equation, for this situation that we're given, when the ball starts at 60 feet above the ground, the initial height is 60. So I know h0 or h sub 0 is 60. I know the initial velocity because it tells me the ball's thrown upward at a rate of 64 feet per second. So the initial velocity is 64, so I'm going to substitute that for v0. And I have negative 16t squared plus 64t plus 60 is the equation for the ball being thrown up in the air. So it models the height of the ball at any time t in seconds. On the previous slide, we determined that our model for the ball was h equals negative 16t squared plus 64t, which was 64 was my initial velocity, and the initial height was 60 feet above the ground. Now, we are asked to find the t-coordinate and the s-coordinate of the vertex. I'm going to change this and say h-coordinate because it's time and height. And what I'm going to do is find the vertex by saying the x-coordinate, or in other words the t-coordinate, can be found by taking negative b divided by 2a. Normally I have an x in the position of t, but this time for the example given we're using t to represent x. So I'm going to say my x-coordinate, or my t-coordinate in this case, is the opposite of b divided by 2a. So if I take the opposite of b, which is negative 64, divide by 2 times our a value, which is negative 16, I get negative 64 divided by negative 32, so time equals 2. What this is telling me is if the ball's thrown up and comes back down, the ball is going to reach a height, a maximum height. Okay, I know that the parabola opens like a frowny face because our a value is negative, but I know that our vertex is at a maximum, and that t value, or the x-coordinate, where the parabola meets the highest point or reaches the highest point, is at 2 seconds. So to find the height of the ball at 2 seconds, I'm going to say h equals negative 16 times 2 squared plus 64 times 2 plus 60. All I've done is I've substituted x equals 2 or t equals 2 back into the equation, and I'm going to determine our height of the ball at 2 seconds. Evaluating this equation at t equals 2, I've determined that our height, h, is 124 feet. So the max height that the ball reaches, the maximum height the ball reaches is at 2 seconds, and that maximum height is 124 feet. In example 2, we're looking at Wright Sports Management, and Wright Sports Management had its monthly maximum profit of $450,000 when it produced and sold 5,500 waste trimmers. Its fixed cost is $155,000. If the profit can be modeled by a quadratic function of x, the number of waste trimmers produced and sold each month, find the quadratic function p of x. Okay, so far there's a lot of information given to us in this problem. We need to find, our goal is to find the profit function. Our profit function, we should know from previous examples, is the revenue minus the cost. Now, there is not enough information to write out a revenue equation or a cost equation. However, there is still enough information for us to write a profit function. Okay, we basically are given some ordered pairs here in the equation. We know that the maximum of the profit function is 5,500, 450,000. We know that when we produce X amount, or in this case 5,500 waste trimmers, our profit will be $450,000. Now, the reason they give us this fixed cost later on is for us to have another ordered pair, which means that if we produce 0 waste trimmers, our profit is going to be negative $155,000 because we still have our fixed costs of, we talked about what fixed costs are before, like paying our employees and our utilities and rent on a building if we don't own the building. So these fixed costs basically are going to be a loss, or we're going to have a negative profit if we do not produce any waste trimmers. So looking at this, we are going to go ahead and find a quadratic equation. We have 2 ordered pairs. One specifically, this maximum is going to be our vertex. And what we're going to do is we're going to use vertex form of a quadratic function. And we know that our x-coordinate and our y-coordinate, or in this case our p-coordinate for profit, are given to us. And so we can go ahead and write the equation in vertex form. Vertex form, the general equation is x equals a times x minus h quantity squared plus k. Remember that h comma k is our vertex, which in this case we know h is 5,500 and k was 450,000. Okay, so we're going to go ahead and substitute 5,500 for h and 450,000 for k. So we get y equals a times x minus 5,500 plus 450,000. And at this point, the only thing we're really missing in our equation is our a value. Well, I'm fairly certain that our a value is going to be negative. I don't know that for sure. But I'm thinking that the profit is going to increase up to a certain point and then decrease. So what we're going to do is we're going to go ahead and plug in the other ordered pair that we had for X and Y, which X represents the number of waste trimmers we're selling. And that other ordered pair was when we sell 0 waste trimmers, our profit or our Y value is negative $155,000. So I'm going to plug in negative $155,000 for Y. I'm going to plug in 0 for X because we're going to produce and sell 0 waste trimmers. And we're going to go ahead and solve this equation for A. Now our only unknown is A. So I can go ahead and simplify this equation by taking 0 minus 5,500. And I forgot a square here. I have to square this because we had a square on our general equation here. And what I need to do is simplify by taking negative 155,000 equals A times negative 5,500 squared, because 0 minus 5,500 is negative 5,500, plus 450,000. So what I'm going to do now, I moved slides here because I was running out of room on the other slide. I'm going to continue solving for A by subtracting $450,000 from both sides of the equation. And that leaves me with A times, I'm going to square negative 5,500. That gives me 302,500,000. And I'm going to subtract negative 155,000 and 450,000. That gives me, if I subtract negative 155,000 and negative 450,000, that's negative $605,000. And if I divide both sides by 302,500,000, which is 30,250,000, that will give me the value of A. When I am done, I see that A is negative 0.02, or if you wanted to write that as a fraction, that's negative 2/100ths. Either or, you can use the decimal or the fraction. I don't care which one you decide to use. But we need to go ahead and write our equation out for our quadratic, which is our profit P is equal to negative 0.02. I'm going to run out of room here. So I'm going to take another slide and write out the equation on the next slide. Our equation should be y equals negative 0.02, that's what we determined for our A value, times x minus 5,500 was our number of waste trimmers produced and sold, and then our profit was $450,000. Now, I could choose to put a P for profit in the place of Y, and X we can leave just as X because that was what they decided to use as a variable for our number of waste trimmers. I guess we could have also used the variable W for waste trimmers, but in the problem they said use X for the number of product produced and sold. In example 3, we're looking at if the points in a table lie on a parabola, write the equation whose graph is the parabola. Now I have to go ahead and give you the table of values. The table of values I want you to look at is x, y, and we have x values of negative 1, 0, 1, and 2, and y values of 13, -2, -7, and -2 again. Based on what I see in these this table of values, I can see that 1, -7 is going to be my vertex. The reason I know that is that I can see my function decreasing from x equals -1 to 0 to +1, and then all of a sudden I start increasing. So this right here in my table at 1, -7 is considered a turning point. I know this is a turning point because my graph, my y-coordinates in my table are switching from decreasing pattern to then starting to increase from there forward. So I know that this graph, since I'm going from a decreasing pattern to an increasing pattern, we decrease first, and then at this point we begin increasing. So we know our vertex is at a minimum. So 1, -7 is going to be considered the minimum on our graph, which doesn't, I guess we already knew that because -7 is the lowest y-coordinate in our table. So 1, -7 is a minimum, and it also is our vertex for the graph. If we're going to write an equation for this table of values, I can use vertex form because vertex form is handy when I know the coordinates of my vertex. In this case I do. We've determined that 1, -7, +1 and -7 are the coordinates of my vertex. So I'm going to plug in the coordinates of my vertex. Again, h and k represent the coordinates of our vertex. So we get a times x minus 1 quantity squared. And then we're going to have a -7 in the position of k because k again is our y-coordinate. So this is h and this is k. So I substituted those values in. And now the main thing I need to do is determine the value of a. And in order to do that, I need to substitute another point that I know that is on the parabola for x and y. Now looking back at my table, I have several values to choose from. I'm going to choose the ordered pair 0, -2 because this was an ordered pair that was in our table on the previous slide. And the reason I chose this point is because x equals 0 is an easy point to plug into the equation and then simplify. So I'm going to substitute -2 for y, 0 for x, and this allows me then to have a as my only remaining variable in the equation, so then I can solve for a. I'm going to get -2 equals a times, if I subtract 0 and 1, I get -1, and if I square that and then subtract 7, I end up with -2 equals 1a minus 7. I'm going to add 7 to both sides here to get the a by itself. So I end up with a equals 5. I added 7 and -2, which gave me a value of a equal to 5. I am not quite done writing my equation. I'm done with all the algebra required, but I'm running out of room here on this slide, so I'm going to go ahead and write out the equation on the next slide. So we've decided that our a value, or determined that our a value is 5. So we get y equals 5 times x minus 1 squared minus 7. Again, because our vertex was at 1, -7. So the 1 goes in right here. -7 goes in right here. This negative sign means that the 1 is positive in your vertex, because the general equation begins with a negative sign if you saw a plus here, that would mean your vertex has a negative x coordinate. So don't take this negative or subtraction sign in front of the 1 to mean that the vertex has an x coordinate of negative 1. If you see a minus sign there, then the vertex has a positive x coordinate. So again, our answer is y equals 5 times x minus 1 squared minus 7. That's the equation in vertex form of our parabola. I could also write it in standard form by multiplying out x minus 1 times x minus 1. X minus 1 squared is x minus 1 times x minus 1. Then I would have to multiply by my coefficient of 5 out in front and subtract 7. So what I get is 5 times x squared minus 2x plus 1. I FOILed out x minus 1 and x minus 1. And if I subtract 7 on the end, I get 5x squared minus 10x. I'm distributing the 5 here. And if I distribute the 5 to the 1, I get a positive 5, and a positive 5 minus 7 is going to give me a negative 2 at the end. So the equation for that table of values can either be written in standard form as 5x squared minus 10x minus 2, or in vertex form as y equals 5 times x minus 1 quantity squared minus 7.